for this one is 9.4. I can design probability simulations. And then the first thing we have to do is fill in the objective for, or the definition of a simulation. So a simulation is an experiment that's designed, to model the action of a given situation. So we would use a simulation when we can't actually perform the probability experiment. It maybe would take too long or be too hard or be unethical to actually perform the experiment, so we will just model it instead of using a simulation. So when you're designing a simulation, it has to have the exact same probability that the actual situation would have. So for our first example, it says a restaurant is giving away 1 of 5 different toys with its children's meals. The toys are given out randomly. Describe a model that could be used to simulate which toys would be given out away with 6 children's meals. So I don't want to go to McDonald's and buy 6 Happy Meals or whatever, because that would be expensive. So I want to design a simulation that I could use instead that have the exact same probability. And so I need to have a 1 in 5 chance of each toy being selected. So we just have to pick something that we know that we could design that has a 1 in 5 chance. So I'm going to pick a spinner with 5 equal sections. So I could get a spinner with 5 equal sections. Now I'd have a 1 in 5 chance of each toy being selected. And then I would have to spin the spinner 6 times because we want to simulate what would happen with 6 different kids' meals. So we would spin 6 times. So we've designed a simulation that would work to model the action instead of actually going to McDonald's and buying 6 Happy Meals, because that could be expensive. So the next one says Mr. Chen must wear a dress shirt and tie to work. Each day he picks one of his 6 ties at random. Design a simulation that could be used to model this situation. And then we're going to use the simulation. Let's use the simulation in class together so we can do that. But let's design a simulation in the video. So we need something that has 1 in 6 chance of each tie being selected. So I'm going to choose to use a number cube. You could choose to use a spinner again or design something else. There's not one right or wrong answer here. It just has to have the same probability. So I'm going to use a number cube since a number cube has the same probability of each side being chosen as the probability of each tie being chosen in this example. So I'm going to roll a number cube, and we would have to roll it until all ties are chosen. So we roll a number cube until we get each number once. Okay, let's go on to the ice cream one. An ice cream store offers waffle cones or sugar cones. Each is equally likely to be chosen. Describe your model that could be used to simulate the situation. We'll actually do the simulation during class. So I need something that has an equal chance of either waffle or sugar cone being selected. So I'm going to flip a coin because that has a 50-50 chance. You could do a spinner and have 2 sections, one for waffle, one for sugar cone. You could roll a dice or a number cube and have evens be sugar cone, odds be waffle cone. There's not one right or wrong answer. We're just choosing something that has the same probability. So I'm going to flip a coin. You can say heads means sugar cone, tails means waffle cone, and we will have to flip it until we get 3 heads and 3 tails. And we'll perform the simulation in class. Flip until you get 3 heads and 3 tails. Okay, during the regular season, Jason made 80% of his free throws. Describe an experiment to find the experimental probability of Jason making his next 2 free throws. So this one we need to design something that has an 80% chance of happening. So what I'm going to do is 80% as a fraction would be 80 out of 100. I know I can simplify this to, I can divide the top and bottom by 20. So I would get 4 out of 5. So I'm going to put the numbers put the numbers 1 through 5 in a bag. And I'm going to draw out two numbers because we're looking for the next two free throws. Draw out two numbers. And I'm going to say 1 through 4 means he makes the free throw. 5 means he misses. So I put the numbers 1 through 5 in a bag. We're going to draw out two numbers. 1 through 4 means he made the free throws, and 5 means he misses the free throw. For your submission to this video, I want you to design a different simulation for this situation. So something else you could do that would give him an 80% chance of making his free throw. So you don't have to do numbers in a bag. You could do a spinner. You could do something else that has an 80% chance of him making a free throw and a 20% chance that he'll miss it. So just type that into the box and then hit submit when you're done.